that for the first we used to use the equations for motion in straight line, which were v is equals to u plus at, the motion in straight line. Now in for motion in curved path, we use omega, for which is used as angular velocity, omega naught, which is used as angular initial velocity, theta, which is used as angular displacement, and alpha, which is angular acceleration. Both of these, acceleration is always constant. Okay, so for the units for angular displacement is radian. For omega, it is radian per second. For angular acceleration, it is radian per second square. So if these are all for when acceleration is constant, but when acceleration is not constant, we use a derivation and integration. So from here we use differentiation, and while going this direction we use integration. Now there are now angular displacement. It is a dimensionless quantity and a vector quantity. Which is always perpendicular to the plane. And for this, we always use the right hand thumb rule. It is written, its dimension is written as velocity. It is a vector quantity and angular parameters. So this is our angular displacement, and this is the radius. So while finding the length of this, we use this formula. The real formula of omega, which is always which is component of velocity perpendicular to the line joining upon length of line joining. Now, frequency, time period, and angular velocity of revolution in 1 second, for which it is, and time period is time taken for one revolution, which is 1 upon f. From this, if we do the derivation of omega, we get 2 pi upon into 1 upon t. Now, acceleration in circular motion. There are 4 types of accelerations. First is centripetal acceleration, which changes the direction of velocity, and always it is towards the center. Okay, its formula is v square upon r, which is also r omega square. Now, the second one is tangential acceleration, which changes the magnitude of velocity and which is always tangential to the circle. Its formula is this, and also r into angular velocity. The third angular acceleration. The third is net acceleration, which is the sum of centripetal and centrifugal acceleration. The fourth one is angular acceleration. If the velocity increases, then we can show it by this. Okay. So if the velocity from here increases till here, then it means acceleration, angular acceleration is also positive. But if it decreases, even angular acceleration is negative. Angular acceleration is equals to and for instantaneous it is so we know that in a circular motion force is equals to mass into acceleration. So as AC is equals to v square upon r, even force is equals to mv square upon r. We have to always remember that in circular motion, centripetal acceleration is very necessary. Now, centripetal acceleration. First is conical pendulum. This is the tension, and equals to m v square upon r, and t cos theta is equals to mg. It's the so here when we remove this, the time period of a conical pendulum is 2 pi root L cos theta upon g. Now next is a car traveling up and down. Okay, so here it is going down. So in this we can see and in downward. So downwards, the normal reaction will go upwards, and mg will go downwards. Here the acceleration will also go upwards. So by this we get to know okay. So now a car traveling in a circular path. So a car is traveling in this direction, there will be friction acting upon it. Upwards, there will be normal reaction acting upon it, and downwards, the mg. So in this, friction will be equal to mv square upon r, and normal reaction will be equal to mg. Therefore, now we will see banking of roads. On first, we will see on smooth road. There's a car going downwards in a smooth road. So the normal reaction will be tangential, and the mg will act downwards. So even this will be theta, and this will be n cos theta, and this will be n sin theta. So and n sin theta will be equal to mv square upon r. Now on a rough road, so as it is a rough road, there will be friction acting upon it. There will be normal reaction tangential to the plane, mg downwards, and there will be friction acting in this direction. So this will be n cos theta. Here it will be n sin theta plus, okay, so in this the friction will also be divided in components. Now we will see a death well. Okay, in a death well, it is sort of cylindrical surface. If an object is moving on the surface, there will be mg acting downwards, and friction equalizes it and does not let the object fall down. There is a normal reaction acting towards the center. So friction in banking of roads, V will be here, tan theta will be V square upon Rg, where V will be equal to Rg tan theta. Now, if in banking of roads, if V is equal to Rg root Rg tan theta, then it will go in a proper path. But if V is smaller than root Rg upon Rg into tan theta, then the cut outwards. Okay, so the car will move downwards and friction will act outwards. V is greater than root Rg tan theta, outwards and friction will act inwards. Now we will see vertical circular motion. हो गया सर. Vertical circular motion. So this is C, B, and A. So when the ball is here, it will always never have tension as zero. So it will always keep on oscillating from here to here, and it does not need its velocity is zero at this point. But when the ball is here, its velocity is not zero, and its tension becomes zero here, which is between B and C. Okay, so the motion from between A to B will always have a tension greater than equal to zero, and the motion from B to C will always have will never have velocity zero. And if tension is greater than zero, it will continue to complete the full circle. Now there are a critical point of velocity. So what is a critical point of velocity? Velocity at any point where t is greater than zero. Okay, so that so for a so the critical the critical velocity of point C is always root gr, and this can be proved by this can be proved. And the critical velocity at B is always zero. Okay, so for for the ball which is at point A, for it to complete the full circle, it needs to have a velocity of root 5 gr. If it has a velocity of root 5 gr, it means it completes the circle. And for this, even the velocity of at point C should also be equal to root gr. If the velocity of point A is root 2 gr, then that means it will go till point B, and if the velocity of point A is smaller than root 5 gr but greater than root 2 gr. It means it will always go till this point D, which is between always, which is between B and C. But if yes, and if it is, if the velocity is root 5 gr, it will always complete the circle. But if the velocity of point A is smaller than root 2 gr, it will just go till this point, which is point E, which is between A and C, and it will oscillate in this way. Um, Now we will see motion of a block on a smooth surface of a bowl. Okay, so this is a bowl. This is a block A, which is got. So every time the block will always leave from this point, which is point B. Okay, so this is the radius R. Okay, this is the point. This is the angle made, and this will be R cos theta. The velocity at point A will always be 0. Okay, so now we will see when it leaves, the normal reaction will act in this direction, and even mv square upon r, which is the centrifugal acceleration, will also be in this direction. Mg will be downwards. In this direction, it will be mg cos theta, and in this direction, it will be mg sin theta. So here mg cos theta is equals to n plus mv square upon r, and which will give us the normal reaction is mg cos theta minus mv square upon r. So by using conservative force, conservation of energy, we can derive it as potential energy at A, kinetic energy. Okay, sir. So, sir, direct answer लिखूं? 3 इक्वेशन लिखूं उसके मेन?
नहीं, जरूरत नहीं.
Okay, sir. So this will give us a normal reaction, which is 3 mg cos theta minus 2 mg. Okay, so and from this we can see that this block, which is block B, will always leave at cos theta, which is equal to 2 upon 3, and its value in degrees is 48.2 degrees. Now we will see ball rotating in a hemisphere. So this was my setup. This was my setup on tin vessels. फोन उल्टा हुआ था, प्रॉब्लम नहीं हुआ कुछ. मैंने फोन 2 के ऊपर रखा था, फिर वो नहीं जम पाया, इसीलिए मैंने नीचे रख के एक इरेजर के बेस पे लिया उसके और थोड़ा टिल्ट करके फोन रखा, फिर वो अच्छे से दिख रहा था नीचे। पेपर्स दिखने में थोड़ी प्रॉब्लम हुई पहले, पर बाद में सर ने बहुत अच्छे से बोला, इसीलिए हो गया ठीक। थैंक यू सर।